All right, let's try to finish up this section today. So we kind of got into a little bit yesterday with the area of the circle, circumference of the circle. And let's see. I don't think we did an example. Did we do the example yesterday? Nobody talking to me? Okay, no example. Thank you. All right, so let's do an example. We did circumference, right? Did we do circumference and area? Yeah, we did both of those. Okay, good. So let's just write it down. So circumference, you could write it two ways. You could write pi times the diameter, or a lot of times we'll write circumference as 2 pi r. Because twice the radius is the diameter, so it's exactly the same thing. Do you agree? Except this is written in terms of radius, this is written in terms of diameter. All right? And then that was their circumference. What does their circumference measure? It measures the what? Okay, you could say it that way. The perimeter of the circle or the distance around the circle. Okay, so when I talk about circumference or perimeter, I always say it's the distance around. Okay, so the distance around the circle. And then we had another formula for area of a circle. Remember what that is off the top of your head? It's got pi in it, right? All the circle stuff has pi in it. That's it. So it's pi r squared. Pi times the radius squared. Okay, so that would be the area of a circle. All right, good enough. Let's do an example using this. So this is example 1. It says find the circumference and the area. So find C and A of a circle whose diameter, I'll just put this, the diameter is what, 10 meters? Okay, so that's all they tell you. They tell you it's a circle, and they tell you the diameter is 10 meters, and you have to find the circumference, and you got to find the area. All right, circumference is pretty easy because we've got a formula that uses the diameter, correct? So you could just put it into this, pi times d. Agreed? All right, so let's do it. So circumference is pi, which is, what are we using for pi? Now, we're not using 22 over 7. We're using a decimal. So 3.14. We're going to use 3.14. Now, remember, it's an approximation, but I'm not going to put like a dot, dot, dot there or anything like that. You could put a little approximate equal sign thing here. I'm not going to be super picky on that. But technically it is approximately. All right, times the diameter. What's the diameter? It's 10, and it's in meters, right? So don't forget your units. You could do this math in your head, couldn't you? Without putting it into a calculator. So what's that in your head? 31.4, right? So it's 31.4 what? Meters. Is it meters squared? No, because it's just the distance around. When we measure the distance around something or just the distance of something, it's just the units. It's not squared. What do we reserve the squared thing for? For area, right? So this is circumference. Now, again, technically, you should put, oops, doesn't look very squiggly. Let's make it squiggly. Now that's really squiggly. All right, so technically, it's approximately equal to, if you put an equal sign, I'm not going to care. Okay, it's fine. Just put equals 31.4 meters. Pretty simple. Do you agree? All right, what about area, though? Formula for area is pi r squared. Problem is, we don't know what the area or the radius is. We just know the diameter. But that's not it's not really a problem, though, is it? It should be pretty simple. So if the diameter is 10, how do I find the radius if I know the diameter? How do I find it? If I know the diameter, what's the relationship between the radius and the diameter? Go ahead, Abby. All right, the radius is just half the diameter. So what would the radius be then? Pretty simple. It'd be 5, okay? It's very important. Just because they give you the diameter and they give you a number doesn't mean you just throw that number into the r, okay? You got to find what r actually is. So r would be 5 because the radius is half of the diameter. We went over that yesterday, didn't we? I showed you the diameter and I showed you the radius. The radius is exactly half of the diameter, so the radius is 5. Now we just plug and chug. So this is 3.14. Yeah, I've never said that in here. Yeah. In my algebra classes. I had a professor in college who used to say that, and so ever since I've been teaching, I always say that. So when you throw numbers into the formula, I've never said that in here. All the times that we've put like X into something, I've never said plug and chug. Wow. In my other classes, I say it all the time. I guess I do. I thought I said it in here, so maybe I don't say it in there. No, I know in my college algebra class, I definitely say it in there. Yeah, that could be part of the reason. All right, so what do we put in here? 5. And I'll put a meters in there just so we make sure we have our units. And what do we do with that 5, though? What do we do? We square it, all right? So it's basically, at this point, you could just put this in your calculator right now if you wanted to. I'm just showing you all the steps, though. So what's this? What's 5 squared? It's 25. And then it's what? It's meters what? Squared, okay? That's why we get the squared, all right? Because we're squaring the 5, we're squaring the meters. That's why we get meters squared. Everybody good with that? If you wanted just to throw the numbers in the calculator and then at the very end just chuck in the meters squared, that's perfectly fine. But I'm just showing you where you get the meters squared from. All right, now it's just a matter of putting that into a calculator. I can't do that one in my head. So that's 78.5. And it is meters squared because it is area. You could put a little squiggle equals if you want to. Again, I'm not going to be picky about that at all. But just understand that it's not exactly 78.5. It's approximately 78.5. And we just rounded it to 1 decimal place. Because this decimal really keeps going forever and ever. Okay, so we just rounded to 1 decimal place just to make it a little easier. I don't know if this problem says, yeah, it does. It says round it to the nearest tenth. Okay, so usually in the problems they tell you what to round it to. So I would say a rule of thumb, just round it to the nearest tenth or the nearest hundredth. So 1 or 2 decimal places. Don't take it out 5 or 6 decimal places. That'd be silly. All right, so 1 or 2 decimal places is good enough. If I don't tell you to round it to a certain decimal place, at least round it to 1 decimal place. Okay, don't just keep it like 79. You follow me on that? So I don't want to round it up to 79. At least give me 1 decimal. To tell you the truth, in science, if you're doing stuff in science and you have 2 decimal places right here, you probably should round this to 2 decimal places. Okay, if this is rounded to 2. But again, I'm not going to be super picky about it. I just want you to know how to use the formula. All right, enough of that. That's easy stuff. I probably should have finished that part yesterday. So let's do some stuff with circles. I'm not going to write down the definitions. I did in my notes, but I'm just going to draw a picture for you and just show you what the definition means and show you the words. Okay, so we have 3 definitions we're going to go over. So definitions. If you really want to write the definitions down, it's right in the book. That's all I did in my notes. I just copied it right from the book. So your first definition is for the central angle. We alluded to this at the very end of class yesterday, but we're going to go over it. So let me draw a circle. And let me move it a little closer if I can grab it. Come on. It's not as easy as you think trying to grab this little thing. All right, there we go. Let's put the center in there. Did you see this program right here? It puts those dots all around there, and then it puts a dot right in the middle. Okay, that is the center of the circle. So I am going to, but I gotta, right there. I have to click off of it before I can draw on top of it. Anyway, that's the center. So what does that mean? The center to any point out here would be what? That would be the radius, okay? So the center can't be like up here, because if you said the center was here, then if I drew this to the circle, that'd be really short and this would be really long, okay? What's true about any radii? Radii is the plural of radius, okay? What's true about any radii on the circle? They're all the what? They're all the same, okay? They're all exactly the same, all right? So if it's in the center and all these lines from the center to the circle, if they're all the same, that's the center of the circle. Everybody got it? This could not be the center of the circle, because if I drew to the circle here and then I drew to the circle like out here, they're obviously 2 different lengths. So there's no way that that's the center. Everybody got it? Because you can't have 2 different radii. It's got to be the same radius. So that would be the radius right there. Now, what we're going to talk about, we mentioned yesterday, is this angle right there. Did you take notes yesterday? We wrote some crazy Greek letter there. Do you remember what it was called? What is it? Theta, that's right. Okay, so it's kind of like a circle with a little curly Q in it, all right? And that we call that theta. It's a Greek letter of the alphabet, just like we have a T or an S or an R or something like that. they have a theta, and that's one of their letters. And we use that a lot in math to represent an unknown angle, right? You could have put an A here or an X or a Z or anything, okay? But usually we put it inside the angle like this, and then we just call it angle theta, all right? It's just very, very common. You'll see it a bunch the more math you take, all right? So this angle right there, guess what that angle is? It's the central angle, okay? Why is it the central angle? Because it's an angle formed by the radii, okay, at that center right there, and it goes all the way to the end of the circle, right? So that's our central angle. Or that's one of the central angles, okay? You could have other ones as well, right? You could have, this would be a central angle right here as well, agreed? But they would be different angles. So all the central angles aren't the same. We just went from here to here, so we call this the central angle. All right, enough of that. All right, let's go to the next one. And yeah, we'll just do the next one right here. The next one is called a sector. I don't know what show I would have heard this on, but I don't know, maybe a cop show or something like that, and they'll say, or I don't know, some kind of Star Wars kind of thing, or in Sector 7. You ever hear anything like that? Okay, well, I'm over in Sector 14. Well, I'm over in Sector 7. Come over to Sector 7. You ever hear that? It's basically like an area of a thing. Well, a sector in geometry is a little more specific than that. So let me tell you what, let's draw. Tell you what, I'm going to copy that whole thing, and then I'll put it right here. And I'm going to get rid of a couple things. Let's get rid of this arrow. Let's see. I'm just going to get rid of all this stuff except for that angle, all right? Now, if I was to do this, do you see the area inside that angle? Okay, all the way. So I'm just shading this in, okay? Just pretend I could color all that space in. That right there is a what? Is a sector, okay? So it's basically like a piece of the pie or the piece of the pizza, okay? I like pizza better than pie, but I like pie too. But anyway, this is like a piece of it, right? It's just a part of that whole entire circle. That's basically what a sector is. Now they give you some fancy definition. It says the region bounded by two radii and the intercepted arc, right? What is the intercepted arc? Well, I'm glad you asked. I call this A, this B, and this C. Do you see this part right here that goes from this one point all the way to there? See that part? That would be considered an arc. Now, in the next chapter, we're going to talk a lot about the arc, but this is just to kind of get us going here. So it says it's the region that's bounded, right? What does that mean, bounded? It means you've got a boundary, right? Okay, like in any sport, right? There's a boundary, right? You're out of bounds, agreed? So this is inside the boundary. This little piece of pie right there is inside the boundary. We used to have a game. You probably don't even know it anymore. I don't know. Trivial Pursuit. You ever played Trivial Pursuit? Nobody? Nobody's heard of it? Wow. Time has flown by. It used to be huge. I mean, everybody had Trivial Pursuit. It was a game, and the little pieces, you would get certain pieces and you try to fill up your circle, and they would be little chunks that look like this right there. And then every question you get right, you'd put a piece in the little pie. And then I guess if you fill the pie up, you win or something like that. If I remember, it's been years since I've played Trivial Pursuit. But anyway, it kind of looks like that. But I guess it's kind of lost on you guys because you don't know what Trivial Pursuit is. But that's fine. So anyway, this arc, this from here to here, see that curved part right there? That's the arc. What's the sector? The sector is all the stuff inside, all right? So it's the area. It's the area of all the stuff inside. Everybody got it? So what do we know as far as area? Area is of a circle. Area is what? Give me the formula really quick. No, area. That's triangle. It's pi r squared. We just finished going over it. Okay, look in your notes. Did you take notes? If you just glance at your notes, it's sitting right there in front of you. Okay, it's pi r squared. So what about, let's talk about it now. What if I had a line from here, and it went through the center, and it went to here. What if, I'm just trying to make this a little easier for us to come up with our formula, all right? I'll make this a little thicker. So what if I colored all this in? I'm not hitting every spot, but you get the idea, okay? If I colored all that in, went outside the lines, I was never very good at coloring anyway. Anyway, that's good enough. All right, that whole part right there. How much of the circle is that pink part right there? It's half of the circle, isn't it? Okay, now let's do something, and we're going to come up with a little formula here. So it's half of the circle. Now, how many degrees, we've talked about this, I think. How many degrees is it all the way around the circle? 360 degrees. So how many degrees is it around half of a circle? It's 180 degrees, isn't it? Everybody with me on that? Because look, this is 180 degrees. We've talked about that. Straight line, right, makes 180 degrees. Everybody with me on that? So it's 180 degrees out of, what's the whole circle? 360. Okay? And what does that give you? It's 1/2, isn't it? So this is half of the circle. Agreed? All right, what if we did this? What if I went from here? Let's see, I went perpendicular, so about right there. Okay, so if this is perpendicular, this right here, I know it's making a mess out of this, but that's 90 degrees. Let's pretend. It's almost 90. It's pretty close. But what if this is 90 degrees? All right, so let's do this in a different color. Let's just do this one right here. So I want to figure out how much of the circle is the green. And how did I get a quarter out of that? Because it was 90 degrees, what? Out of 360. No, not 180. It's 90 out of the whole entire circle. All right, everybody see it? The green one? Okay, it's 90 out of 360. Well, the zeros cancel. What's 36 divided by 9? It's 4, so it's 1/4 of the circle. Everybody get it? Okay, or if you wanted to write it as a percentage, you could write it as a percentage. What would that be? It would be 25%, or 0.25. You put that in a calculator, and it could also be 25%. Everybody with me on that? Okay. What if I wanted to find the area? Let's stick with the green one now, okay? What if I wanted to find the area of the green sector? All right, this is called a sector right there, okay? It's a chunk of the circle. What if I wanted to find the area? I'll put G for green, is that right? So the green sector. How would I do that? Well, first of all, what's the area of the whole entire circle as far as the formula? What's the area of a whole circle? Pi r squared, right? Pi, oops, I forgot to put the r first. There we go. Pi r squared. But we're not finding, the green is not the whole entire circle, is it? It's how much of the circle? It's 1/4 of it, or how did we find 1/4? We went 90 over what? 360. Would you agree? Okay. What if I wanted to find the area of half the circle? Put h right there. Then what would we do? It's pi r squared. You're right. We would go 180 over 360. Everybody see that? What if this angle right there was 30 degrees? Looks a little bit bigger than 30, but that's okay. We'll say 30 degrees. What if I wanted to find the area? I'll just put a little 30 down there, okay? What if I wanted to find the area of a sector that has a central angle of 30 degrees? How would I find it? Well, remember, the whole circle is pi r squared, but we're only finding 30 degrees out of what? The 360, the whole entire circle. Okay, so how would I find the area of just this sector right there if that angle is 30 degrees? I would go 30 out of what? Out of what? Come on, I've done it twice. Come on. 360, right. Everybody with me on that? So if I gave you an angle and I said find the area of that sector, with that central angle. Okay, you would just go that angle divided by 360 times pi r squared. And that would be the area of that. Now, I don't know what the radius is on any of these. I'm just doing this in general. What if I asked you to find the area of a sector that's like 17 degrees? What would you do?
17 over 360.
Exactly. Now you're getting the hang of it. Yep, 17 over 360 pi r squared. Did you follow me? Now, here's the formula that they give you. Okay, they give you a formula. Yeah, it's a theorem. But it's basically, I'll just write this down. It's a theorem. And it's the area of a sector. Okay, so it's basically a little formula to find the area of a sector. So the area, we'll put S for sector. Okay, the area of a sector is how many degrees, right? Whatever the central angle is. And what did we originally call that central angle without all that junk in there? What did we call that central angle? Like an unknown angle. Theta. We call it theta. Okay, it's Theta, but that E kind of sounds like an A. At least that's the way I say it. And most people, English people anyway. I don't know how Greek people actually say it, but that's how I've always heard it ever since I took my math classes. I actually had several Greek friends when I lived in Australia. There's a huge Greek population where I lived, and I had a bunch of Greek friends. But I had no idea what theta was back then, and so I had no clue to ask them. I was only 8 years old. So, but if I knew somebody that was Greek, maybe I would ask them how to actually pronounce it. But I say theta. So how do we find the area of a sector? Just any sector. What do we do with the angles? So theta, instead of all these angles, what are we going to write? We're going to write theta divided by what? 360. Okay. Again, the theta just means whatever our central angle is. Okay. So whatever our central angle is, we divide it by 360 and you multiply it by pi r squared. So that right there is your general formula for the area of a sector. Do you understand how we get it now? Okay, I showed you with numbers, right, that kind of made sense. We took half the circle, then a fourth of the circle, then we took 30 degrees out of the circle, then we took 17 degrees out of the circle. But every one of those has the same exact formula, except for the angle, right? The angle could change depending on the angle, right? So the angle we call theta, put it right there, divided by 360 pi r squared. It's pretty easy, isn't it? Yeah, it's pretty simple. We got one more. Let's see. Let's get rid of some of this mess right here. Let's get rid of that. Let's get rid of that. And now watch what I'm going to do. What is this little area right here? This little blank area right there. That's called a what? Sector. Watch what I'm going to do. I'm going to connect where both of those radii connect with the circle. So I'm going to connect from there to there. Okay? And now what I'm going to do is I'm going to shade in this little bit right there. Now, is that a sector? Now, the sector goes from the central angle, right, all the way to here. So the sector would be that whole entire thing shaded in, right, like we did right there. See that yellow? That's a sector. That's all shaded in. But we took the sector, and we just want to find out what's left over after you figure out the area of this triangle. Everybody see that? Everybody's watching, right? So this little bit right there, we don't call a sector. They call this a segment of a circle. The segment doesn't just mean the straight line. It means the area. It means that it's that little space, okay, that's between the arc and that connection of those two radii. You see that? So that little bit right there is called the segment. So how in the world would we find the area of this segment? We'll do an example here in a minute. All I'm doing is explaining this, but let's just think about it. What if I wanted to find, what if I knew that angle, okay, and I wanted to find the area, and I knew the radius, I wanted to find the area of this segment. What in the world would I do? Well, I could find the whole entire radius, or the whole entire sector, couldn't I? So what would the area of the whole entire sector be? I'll just write sector right there. What would the area of the sector be? It would be what? Theta over 360, what? Pi r squared. But that's not what we're trying to find. We're just trying to find this little bit right there that's shaded in. So the sector would be from here to here and everything in between. So how would I find just this segment of the circle, just that shaded in part? I would take the whole sector and take what away from it? The triangle, right. So I would take the sector and subtract the what? The triangle. So what's the area of a triangle? You got it. It's 1/2 the base times the height. Now, you don't have to memorize this thing right here. I'm just showing you what you're thinking in your head, all right? I mean, you could memorize it. But so how do I find the area of a segment? Well, I find the area of the sector, and then I do what to it? I take away the area of the what? The triangle. That's right. Everybody see that? So that's how you would find the area of the segment. Again, we know how to find the area of a sector now. It's theta over 360 pi r squared. We know how to find the area of a triangle. We've discussed that earlier in the chapter. It's 1/2 the base times the height. And then once you take the whole sector, once you take the triangle away from the whole entire sector, guess what you're left with? You're left with this little bit right here, which is the segment. You see what we're doing? No? Okay, look.
I'm gonna have to watch videos.
So watch. Here's the sector. I'm going to shade it in for you. And it's not going to be pretty, but okay, look. See that right there? All that. Should have made my brush bigger. That's called a sector. Everybody see that? It's like a piece of the pie. Everybody with me? Okay, that's called the sector. So right there, the area of the sector. How do I find that area? Well, it's not the whole circle. It's just a part of the circle. Okay, so depending on what the angle is, so if it was like 45 degrees, how would I find the area of all that yellow right there? I would go 45 out of, oops, there goes my pen again, out of 360, right? Because 360 altogether, and then what? Pi r squared. So instead of the 45, I don't know it's 45, but I do know it's theta. So instead of writing 45 over 360, just any general sector would be theta over 360 pi r squared. So that's how you find the area of the sector. But that's not what we're trying to do now. We did that in the other example. Okay, we're not trying to find the sector right now. We're trying to find what's left over. So let me get rid of all this yellow. Let's see.
So what does the theta represent?
It represents the angle. Okay, let's get rid of all of that right there. What are we trying to find? We're trying to find that white part right there. Everybody see that? No, theta is an unknown angle. Listen to me. Theta is not a number. Theta represents an unknown angle. I could have put an A here, right? And I said, what's angle A? I don't know. Okay, but we don't. Sometimes we do that in math. But a lot of times, the higher up you go in math, the more you're going to see theta. You're going to see it a lot. All right? So this is our first time seeing it. It's basically a variable, but a variable that represents an angle. Does that make sense? So that's what theta is. It's not pi. It doesn't equal anything until I tell you what it equals, okay? If I said that this angle is 45 degrees, then what's theta? 45 degrees. I could say theta was 30 degrees, all right? It's a variable, okay? It's just a weird-looking letter. It's a Greek letter of the alphabet that represents an unknown angle. Does that make sense? We got it? Okay. So that's what theta means. So whatever the angle is divided by 360 times pi r squared is the sector. That's the whole thing that I had in yellow earlier. But what are we trying to find? We're just trying to find the segment. So if I could take the triangle away from the sector, what's left over? The segment. And that's what this formula is right there. Okay, so to find this little bit right there that's left over, I got to find the area of the whole entire sector, which was in yellow. I erased it, but was in yellow, minus this triangle, and that's what's left over. And that's how you find the area of the segment. See it? Okay. All right, so now let's do an example, and we will be finished. Yep. All right. Let's put this in here again. Should have copied it without all this junk. Let's just make a new circle. Let's just start from scratch. All right, there we go. We'll make it pretty big because I'm going to do a little bit of writing on it. Look at that. I grabbed it the first time. All right, let's not start talking yet. Let's wait until we're finished. Okay, so let's do this. We'll go like this, go like this, and we'll go like this. Okay? And I'm going to put some numbers in now, okay? We're not talking real general now. We're going to be specific and put some numbers in here. So, let me look in the book real quick. I just want to make sure I wrote it down right. I did. Okay, so let's say that the radius is 3. Everybody with me? That's the radius, isn't it? Because it goes from the center to the circle. And then this little bit right there, we're going to say is 4. Okay, where I connected the two radii. You see it? Okay, we're going to say that's 4. And I believe, yeah, they say that this is 84 degrees. So that's my what? It's my central angle or my theta. That's my theta. It's 84 degrees. Okay? So what we're trying to find, let's see what they ask you for. Yeah, they ask you for the segment and the segment. All right? So the sector and the segment. So the sector is from here to here to here. It's all that stuff right there. Agreed? All right, let me scooch it up because we don't need the top of that circle. That's good. That's all we need. So what we're eventually trying to do, basically, is to find, what do you think? This segment. So let's just do that. Yeah, I'll just do it like this. So this is what we're trying to find the area of. Everybody got it? So we're trying to find the area of the segment. Let's turn that back to whites. So what do we have to do? If you looked at that little formula thing I gave you, we find the area of the sector, then we find the area of the triangle, and then you subtract them, and then you got what's left over. Okay? So the sector's not hard. It's the triangle that's the hardest part. Okay? It's not 90. What's the angle? It's 84. Okay? So it's 84 over 360 pi r. Now we know the r this time. What is it? It's 3, and it's squared. So that's the area of the sector. Did I write down what that was? Yeah, it's approximately 6.6. This is all in centimeters, by the way. All right, so it's 6.6 centimeters. So that's the area of the whole sector. Is that the green part? No, it's from here to here, here to here. It's that whole thing if I would color it in. It's too messy for me to color everything in, though, okay? So that would be the area of the sector. No trapezoids here. So now what do we have to find? The area of the triangle. So how in the world are we going to find that? Well, the area of a triangle is 1/2 the base times the height. Okay? We got to find the height. Exactly right. So we know what, though? We know the base, okay, which is 4. Okay, we got to find the height, though. So where is the height? Well, it's from here, and it's perpendicular. Remember, the height is always perpendicular? Yeah, we could say straight down, but I like to say perpendicular, okay? Now what happens? Now remember, this was an isosceles trapezoid, wasn't it? Because this is a radius, all right? This has to be the radius as well, okay? So it is an isosceles trapezoid. What does it do when you make a perpendicular to an isosceles trapezoid? It bisects that angle right there. So what's this angle right there? It's 42. Okay? Couldn't think of half of 84? Okay, half of 8? Half of 4? Okay. So let's watch. So what are we trying to find on this triangle? We're trying to find the height because we know the base is 4, correct? So how in the world can we find the height? Well, Actually, we don't even need to know that that's 42. But we know it, all right? I'm looking at it, I'm like, wait a minute, we don't even need to know that because we know some other things. This is 3. I don't know the height. What about this little part right there? It's 2. That's right, because, again, isosceles trapezoid, it's a perpendicular bisector, all right? So this right here would be 2.
Wait, is this is a...
It is. What's the word? It's a right triangle, okay? I know a hypotenuse. I know one of my legs. I got to find the other leg. What do we use? What's the name of it? Say it. Pythagorean theorem. That's it. It's Pythagorean theorem, which is a squared plus b squared equals c squared. See how that stuff that we learned earlier is coming into play here? All right. That's the cool thing about math. Well, as long as you learned it before, it's a cool thing. But if you didn't learn it before, it sucks because you're like, oh man, I should have learned it back then. Well, let's learn it now. So what's my A, my B, and my C?
Your A is 2.
Well, let's do the H first. Is that all right? But you could call it 2. It doesn't matter. So here's the H, or there's the A. This is the B. And then what's the C? The 3. And let's do the math. So H squared, what's this going to be?
4.
Plus 4, what's that going to be? 9. So H squared is what? 5. So I square root both sides. So H is the square root of 5. Okay? So what do we do with that? Well, we found that we have to find the area of the triangle, right? So what's the area of the triangle? It's 1/2 the base. What's the base of this triangle? It's 4. It's not 2 because I'm trying to find that whole entire triangle. Okay? It's 4. So it's 1/2 the base times the height. What's the height? Square root of 5. Now we have a calculator, so that's what we're going to do. We're going to put it into a calculator. So 1/2 of 4 is 2. It's 2 square root of 5. If you take 2 square root of 5 and put it in your calculator, you get approximately 4.5. Okay? Because square root of 5 is just a little more than 2. You understand why? Because the square root of 4 is 2, right? And square root of 5 is just a little more than the square root of 4. So this is going to be a little bit more than that. I subtracted 4 from both sides. I subtracted 4. Thought you could do that in your head. That's why I didn't put that step down. All right. So subtract 4. 9 minus 4 is 5. Take the square root to get rid of the square. And that's how I get it. All right. So look, what is this? I'm not circling it because it's my answer. But what is that right there? That's your sector. This is your triangle. So what do we do to those two numbers to find the green? You subtract. That's right. So it's 6.6 minus 4.5, which is what? 2.1? Yeah. Now, at the end, I'll put the approximate, okay? 2.1. Now, this is area, and this is in centimeters. So what's your answer? Centimeters squared. Okay. Now I'll circle it. And that's the area of the green section right there. It's called the segment. Remember, it's called the segment of the circle. Okay? Well, you got to think. Okay? All right? You got to think. Gone are the days where we just do one little step and we get an answer. You're going to have to think a little bit. All right? That's life. You got to think. All right. Let me give you a little homework. Right, so you got a bunch of time to do it.
Oh, I guess it's checking for it.
I didn't give you a whatchamacallit, lesson plan thing. Whoops.
I've never had it. Wait, is this on YouTube?
It will be on YouTube. Write it down though.
Where did you go?
There it is. That's your homework right there, okay? Yeah, I want that worksheet, that square root worksheet thing. Okay, so put that on my desk before you leave, right here. And that's your homework. You got plenty of time to get this done, all right? I should give you 2 homework assignments since you got 3 days plus a weekend. But I'll just give you the one.